Hello. Hi. Hello.
Hello.
Hey, how are you
等一下，等一
today?
下，你没有 background
你有 background 有啊？background
哦，你讲你的 background 是怎样的 background？你
yeah. This is
show
the background.
你的
This is the background I'm talking about the background. So it's it's okay. Right. So so today, right, we will be learning about trigonometry. So we have done with probability last week. So today we will learn about trigonometry. I told you trigonometry is very important for exam because it will consist about 12 to 15 marks, depends on the situation. And it's a very lengthy chapter, even though you have learned some of it during your maths, modern maths, but yet it is something new to you also because there's a lot of drawing graphs and then finding solution. Okay, but no worries. Okay, it's not difficult. Okay, so let's get ready. Just get ready for the lesson, and then you just take out a piece of paper for now. All right. So and then we will start. Okay, let's go and get a
Okay.
piece of paper.
Yeah, I'm ready.
Right, hi. Okay, so today we will look into trigonometry. So let's see. All right. So we learn in trigonometry, we are talking about, what is trigonometry? Trigonometry is talking about the relationship between angle and sides, right? The angle and the side. So from what we learned previously, right? Let's say I have a right angle triangle, okay, and if you want to find the right angle triangle means that there's one angle here that's 90 degree, right? And if you want to find, right, the length, let's say you have A, B, and C, okay, you will be able to find the length by using what method you use. If you want to find A, B, and C, or let's say you want to find B, given A and B, what you use, what method you use.
Um, what is it called again?
What is it called again? We will use to find the sides, right? We will use Pythagoras.
Yeah, Pythagoras.
Okay, Pythagoras.
Theorem Pythagoras.
Yes, so it will be C square equals to A square. Okay, C square is equals to A square
So
plus B square.
plus B square.
Yeah, so that is for side only, right? Means that you want to find side. Okay, then we also learn that, right, in triangle, right? In triangle, let's say, right, you give you a triangle and this is still 90 degree here. Okay, this is 90 degree. And you know the side, let's say you know this angle, right? Let's say this is side A, this is the point A, this is B, right? This is C. Okay, this is C, right? Let's say you know that this angle here, right, is, let's say 40 degree. Okay, 40 degree. Yeah, 40 degree. So 40 degree. Okay, 40 degree here. So what is this value here? This x here. Let's say I want to find this angle here, x. How you calculate?
Use Sokatua.
No, why you use SOHCAHTOA? I want to find the angle. So we know that angle inside a triangle add up together give you what?
100 and 180.
Yeah, very good. So you want to find angle, we'll take 40 plus 90 plus x equals to 180. Correct? Therefore, you have 130 plus x equals to 180. So your x is equals to 180 minus 150 degree. Okay, 130, sorry, 130. So your x is equals to 50 degree, right? So you see, if we want to find side, we always use this method, right? Pythagoras theorem. But if we want to find angle, we will use this method, okay? But what if I want to use the side to find the angle? Or use the angle to find the side? This combination means that this one, right? This one that you have is just to find the side. Okay. This method that you have is just to find the angle. But now you want to find both of it. Means you want to use the angle to find side or use side to find angle. In this case, trigonometry is it. Trigonometry is a concept we have that relate the side and the angle.
Oh, okay.
Okay. All right. So that is what we mean by trigonometry. So the three basic trigonometry that you have learned before is sine, cosine, and okay, which is sine. Okay, let's say you have, okay, let's say we have a right angle triangle. Okay, we have right angle triangle, and I'm talking about this angle here now, right? Let's say I'm talking about this angle. This is my angle. Okay, and this angle now that I have, right, is x now. So can you tell me which one is your hypotenuse? Which one is the hypotenuse? Let's say I have A, B, C, D also. Okay, I have A, I have A, I have B, and I have C. I have B and I have C. Which one is your hypotenuse?
AC is my hypotenuse.
AC is your hypotenuse. So this is your hypotenuse. So I'm going to guess HYPO, hypotenuse. Right? Which one is your opposite?
AB.
AB. So this is opposite, right? So which one is adjacent?
BC is adjacent.
Right? So BC. So we know that, right? We want to relate, okay, adjacent ADJ, ADJ, right? So we want to relate, right, the angle with the sine, cosine, and tangent. So we learn that sine x is equivalent to
sine x is equal to opposite
over
hypotenuse.
Over hypotenuse. All right. So it's hypotenuse. So we know that this is solved right now. Solved. Okay. Then the next one you know is what? Cosine x is what? Cosine x is
adjacent over hypotenuse.
Over hypotenuse. Adjacent over hypotenuse. Very good. Hypotenuse. So it's ka. Right now. Okay. And you also know that, right? Tangent x is equivalent to
adjacent over no, it's opposite over adjacent.
Over adjacent. Right. Very good. Okay. So this is TOA. So this is the three basic one. TOA. Okay. Three basic identity, the trigonometry that we have. Okay. You see, right? You see the angle, right? We are looking at the angle. We relate the angle with the side. But previously, right? You see this one, right? Pythagoras. We are only looking at the side only. We don't talk about the angle one. This one, we talk about the angle only. We don't talk about the side one. Okay. But trigonometry will talk about both the angle and the sides.
Okay.
Okay. So now, can I write tangent x as something else? Right. So now you look. Okay. Tangent x, right? Tangent x. Okay. Let's say like I want to show this. Okay. If I have sine x over tangent x, cosine x, what this will give me? Think about it. What is going to give you? Sine x over cosine x.
Opposite over hypotenuse over adjacent over hypotenuse.
Very good. Okay. So basically this is just what? This is just sine x divided by cosine x. Right now. Right now. Yeah. So which means sine x is what? Sine x is opposite over hypotenuse, right? Divide by cosine. Cosine is what? Cosine is adjacent
over
hypotenuse. So hypotenuse. Okay. So but then we know that in divide, right? When it's divide, you want to change to multiply. The one that behind will be flipped. You flip the behind one. So it becomes hypotenuse divided by adjacent. Right? So the hypotenuse and the opposite, right? And the opposite, the hypotenuse here, okay, and the hypotenuse here can be cut off because it's up and down, the numerator and denominator. Okay, so what do you get in the end?
Opposite
over
adjacent.
Right? So which is what? Opposite over adjacent is what?
Sine and cos.
Sine over adjacent is what? Look at it. Opposite over adjacent is what?
Oh, it's tangent.
Tangent, right? So tangent. So this is a new identity that you have.
So which means that sine over cosine is equals to tangent?
Yes. So which means that tangent x can also be written as can also be written as sine over cosine. It can be written as this one. So next time in the future, right, sometimes, right, you need to know that tangent x can be written as sine x over cosine x. So this is something new to you. Okay. This is the basic one. This one is the one that you learned before, right? But today, right, we are looking at this kind of functions. So tangent x is equals to sine x over cosine x. Okay, right? So these are the basic three. Okay, but in maths we have another 3 extra one. So the first one, right, the first extra one is called as second x. Okay, SEC(x). But the real name of it, right, how do we read this thing? Is called as second. It is called as second. So which way? Right? It is called as SECNT, second.
Oh, I thought was the one and second, first and second.
No, it's not. No. It's SECN, but we don't write the long one. We just short form and write second only.
Okay.
Okay. So this is equal to what? Okay. It is equal to 1 over. Now, S, right, sound like sine, correct not? But it's not. Remember that. If it's second, then it's divided by 1 over cosine x.
1 over cosine. Okay.
Okay. The other one that we have, right, is called as CSC lah. Okay, CSCx, or sometimes they will write it as cosecant. So I won't write cosecant so that you won't confuse. So I will write as COS cosecant. Okay, SEC. So I will put it like that. Okay, cosecant. Okay, second x. Okay, but sometimes in work textbook, right, they write CSC. It's the same thing, CSC. Okay, but I here write cosecant. The name of it, right, is called as cosecant. So it's CO cosecant, cosecant. Okay, so what do you think? Now it's C, right? So it's 1 over what?
1 over sine.
Very good. 1 over sine x. Okay. So you see, right? You have to know differentiate, how to differentiate. If it's S1, you think that it's sine, but it's actually not. It's cosine. But if you think that it's for C1, right, cosecant, you think that it's cosine, but it's not. It's sine.
Then how about tangent?
Tangent is called as cotangent. So it's cot x. The name of it is called as cotangent.
Okay.
Okay. So it's called cotangent, right? So the formula is 1 over
tangent.
Okay, so you have a new function that we have. Second x, cosecant x, cotangent x, like that.
Okay.
Okay, now, if tangent x can be written as this one, what is cotangent x going to be like? If I want to write cotangent x as sine and cosine only, how are you going to write it?
1 over sine cosine?
No, I'll show you. Okay, see. 1 over tangent x means 1 divide by tangent x. Right? Okay. So this is going to give you 1 divide by what is tangent x? Tangent x just now is sine x over cosine x, right now.
Yes.
Okay. So now you make this one into multiply. Okay, it will become what? Cosine x
cosine over sine x.
So what is this? Cosine x over sine x.
Sine x.
Right on. So therefore, right, okay, if you want to write cotangent x, it is also can be written as cosine x over sine x. You see, it's inverse. Tangent is sine over cosine. Cotangent because 1 over then become cosine over sine.
Just flip.
Just flip. Yeah, you just flip it. Okay. So how do we use these kind of things, right? We learn that in order for us to solve for this kind of trigonometric questions, we will need to use our calculator right now. So let's say, for example, I'll give you an example. Okay, I have sine x, okay, sine x, okay, equals to 0.678. I want to solve, okay, find the value of x. Find the value of x. Find the value of x. Okay, for x, oh God, for x in between of 0, in between of x, in between of 360 degree. So your answer is must be in between of 0 to 360 degree. Okay, I want to find this one. So how you going to do this kind of question? You learned that in maths before. How you do?
Use it anti-sign.
Very good, right? But what you going to write? Okay, every time when you do anti-sign, right, you must write basic angle. Basic angle. Okay, so you must always write the basic angle because your anti-sign will only give you the basic angle. So it will become anti-sign of 0.678, which will give you what? Press calculator, right? So you see press calculator.
42.69 degree.
Okay, good, right? So you shift anti-sign 0.678. Right. So 42.69. So you have 42.69 degree. Okay, yeah, degree. Right? But this is not the answer. You're not done yet. So what you need to do now?
I don't know.
Okay, you need to compare with the all science teacher crazy, the ASTC. You remember that? You remember?
Not quite.
Right, not quite. No worries. So now what happened is that this is your ASTC, right? So here, right, is 0 degree. Okay, always start from here. Always start from this part. This is always 0 degree. Okay?
Always start from right side.
Yeah. Okay, I'll explain to you later why is it like that. Right? This is 90. This is 180. This is 270. 270, and it will end here at 360. Okay, can? Right? So what happened is that, okay, we will always refer back to our graph. So if you look at it, right, there's more. Okay, I'll show you my graph. Okay, if I am to draw the tree graph outright, okay, sine graph is like that. This is sine graph. Okay, and I'm looking at only right from 0 to 180 degree. So I'm going to put it into degree. So I'm looking at x from 0 to 360 only. Okay, try to look at this one, 360. Right, my y is from -1 to 1. So you can see very clearly what's going on. Okay, maybe -1.5 to 1.5. Okay, you see the graph, okay, so this is your graph. Maybe make it smaller so you can see. I'm looking at x equals to 0, okay, here, until x equals to 360. I'm looking at these two parts only, these two regions only. The rest I don't want. Okay, can I? Now, let's say I put another graph, y equals to cosine x. This is my other graph. The purple color is my cosine graph. The red color is my sine graph.
Okay.
And if I have another graph, y equals to tangent x. This is my tangent graph, the black one.
Wow, okay.
Okay. I am looking at now 0, 90, right? 360. You see my quadrant, right, is 0, 90, 180, and 270. Right? There are 3. So I'm looking at the graph of 0, x equals to 90, right? X equals to 180, right? X equals to 270. I know it's a bit hard to see now, 270. Later I off it, you'll be able to see clearly. So let me change all the color here, right, to blue. So it's easy for us to see. So this is blue, this is blue, this is blue. Okay, now look, I close my tangent and sine graph. I'm looking at the blue line, this is from 0 to 90. This is 90 to 180. 180 to 270, 270 to 360, until here only.
Oh, okay.
Okay, from 90 to 0 to 90, right, your graph is positive or negative?
Positive.
Positive. So you know that
up.
0 to 90 is positive. Not about going up. You see your value. It's more than 3. So here, right, you know that sine is positive. All right. Okay, now let's look at the next one. From 90 to 180, what happened to your graph?
Negative.
Positive. Your graph, you see your value from 0 to 1.
It's still
Yeah, it's
yeah.
decreasing, but your value is positive. Okay.
Okay.
So from 0 to 90, 180, sorry, from 90 to 180, your sign is also positive. Also
Okay.
positive. Okay. Also positive. Then let's look at the next one. From 180 to 270, what is your value here?
Negative.
Negative. So I know that 180 to 270, my sign is negative. Sign is negative. Okay. How about the other one? Let's look at this one. What happened here?
Also negative,
Also
even though
negative.
it's increased.
Yes, even though it's increasing. So this is sign negative also.
Okay.
Okay, so if we do the same for tangent now, okay, we do cosine now. Look at cosine. What happened here? The first part, positive, negative. Then
Positive.
here what?
Negative.
Then here lah.
Negative.
Then here.
Positive.
So which means that positive, negative, negative, positive correct now. So that's why here is cosine. Cosine is positive. Okay. Here cosine is negative. Here is cosine negative. Cosine negative. And here is cosine positive. Right? Okay, that's done. Let's look at tangent now. Right? What happened? Here is what?
Positive.
Here?
Negative.
Here?
Positive.
And here?
Negative.
So positive, negative, correct now?
Yes.
Yeah, so that's why, right, we have tangent positive, okay? This is tangent negative, right? This is tangent positive, and here is tangent negative. Tangent negative. Okay, so now, because of this one, right, you can see all of this, you can see, right, here, right, all of it is positive. That's why I call this one as A. All of it is positive. That's why I call A.
Oh.
Okay.
Okay.
Here, what is positive?
Sign.
Sign. So I call it S lah. Okay, so I call it S. Here, what is positive?
Tangent.
Tangent is positive. So this is tangent positive. Okay. Here, what is positive?
Cosine.
Cosine. So C lah. Right on. So how do we memorize this this quadrant? ASTC. Add sugar to coffee. All science teacher crazy. So we usually use all science teacher crazy.
Okay.
Okay. So this is very important to us. Why? Now look back at this question here. You get your basic angle, right, as sine negative 1, 0.678, which is equal to 42.69. Your sine, right, is positive or negative?
Positive.
Positive. So where is it?
Because it's between between 0 to 90 degrees. So
no, you don't think like that. You look at this value here. This value 0.678. Positive or negative?
Positive.
Positive. That's why it falls into positive. Where is it positive? A and S. Because A is all, S is sine positive. Correct? So therefore,
So
right,
we don't look at the basic angle value.
we look at this value, right? We look at the basic angle, but this value will tell us which quadrant it is. It means that it falls into which box.
Oh, okay.
Okay, because sine is positive, it falls the first and the second one. Okay, so which means that now I know that, okay, my angle will be here, and here. Positive. These two angles. Okay. Yeah. Okay. You must remember that the angle 42.69 always stick to the horizontal line. So the angle, right, is here. Not here. It's always horizontal. This is the horizontal line. We are talking about this line.
Okay.
Okay. This angle always stick to the horizontal. So it's here and here. The angle must form here. Okay. So now I want to find what? Actually, the angle that I'm looking for is always from 0, from 0 here. You want to find this angle, Okay, this is the angle you're looking for. Right? and also this angle that you're looking for.
Okay.
Okay. So how to find this angle? This angle is just what? 0 to 42.69. Right? So your first angle, right, is just x equals to 42.69 degrees. Okay. The second one is what? You see, you want to find this angle now from here, right, to here. How you find this angle? You take 180. Yeah.
180 minus 42.69 degrees.
Yes, 42.69 degrees. So what you get?
137.31.
3 1. So 3 lah, because 3 is a 4 similar figure. Ma. So this is
Okay.
so this is your final answer. You have two answers, one in the end.
Oh.
Because the answer is between of these two. Between 0 and 100, 360.
So this chapter is similar to the modern maths.
Almost. But later on, you
6.
have double angle and things like that. I will show you. But I just want to recap this one first.
Okay.
Okay? Right. So wait. Right, so that's all for today. All right, I hope that you understand what I'm talking about. So we will see each other again next week. Is that okay? Right, so yeah, so that's all for today.
Thank you for the class. Bye bye.